Hey everyone, I'm a professional blockchain developer, and today in this video we're going to talk about something really cool, the TON blockchain. So if you are a Solidity developer or just curious about blockchain in general, you have found the right video. In this video, we're going to take a smart contract written in Solidity and convert it into text step by step. Sound good? Let's do it. Right. Before we jump into the code, let's talk about the key differences between Ethereum and TON. I came across a fantastic article from the TON blog that highlights 6 unique aspects of TON that will likely surprise you. So first one is your smart contract needs to pay rent and charge its users. Unlike Ethereum, where you pay a one-time fee to deploy a contract, on TON smart contracts need to pay continuous rent for the resources they use. Think of it as owning a property versus renting an apartment. On Ethereum, once you bought the house, that is deployed a contract, you don't need to pay any more fees. But on TON, you are more like a tenant, paying rent as long as your contract is active. If your contract runs out of funds, it gets deleted, although it can be recovered later. This model is more scalable because it ensures that only active and funded contracts occupy space on the blockchain. Next up is calls between smart contracts are asynchronous and not atomic. So Ethereum allows smart contracts to call each other in a single transaction that either completes fully or rolls back completely if something goes wrong. This is called atomicity. On TON, however, calls between smart contracts are asynchronous, much like how microservices communicate over a network. This means that when your contract sends a message to another contract, the response doesn't happen immediately. This can introduce challenges like ensuring data consistency and handling failures, since you can't simply roll back the whole transaction if something goes wrong. Third point is your smart contract cannot run getter methods on other contracts. On Ethereum, it's easy to query data from other contracts, right, using getter methods. But on TON, since all communication is asynchronous, smart contracts can't directly access each other's state. Instead, they communicate by sending messages, which means you can't instantly get data from another contract. This is a significant shift in how you'll design your smart contracts, requiring you to think about how and when you will need data from other contracts. In Ethereum, when you make a call to another contract, it's like having a face-to-face conversation. It all happens in real time. But on TON, it's more like sending a letter. You write it, send it off, wait for a reply. This means you've got to be patient and plan for the possibility that things might change while you're waiting. Next is, smart contract code is not immutable. You can easily modify it. One of the cornerstones of Ethereum is the immutability of smart contracts. Once deployed, a code cannot be changed, which is great for security, but not so great if you want to fix bugs or update the contract. On TON, however, smart contracts can modify their own code, make them more like software that can be updated over time. Next point is you should not have unbounded data structures in your contract state. On Ethereum, it's common to use data structures like maps or arrays that can grow indefinitely, thanks to the way gas fees are structured. But on TON, unbounding data structures can become very expensive to maintain and even lead to denial of service attacks. Instead, TON encourages developers to use smaller, bounded structures or to shard large data sets across multiple contracts. And the last point is wallets are contracts and one public key can have multiple wallets deployed. On Ethereum, your wallet address is tied directly to your public key and it's a one-to-one relationship. On TON, however, wallets are actually smart contracts that must be deployed, and a single public key can be associated with multiple wallets. This opens up a new possibility, such as having different wallets for different purposes, each with its own unique behavior. It also means that wallet management is a bit more complex.